Right, so tonight we're going to have a first look at the new .NET SPA SPA framework that's come out of Microsoft in the last few months. This is a first look. This is not a really in-depth look because I didn't know much about it until 2 weeks ago when I started looking at it in order to do tonight's presentation. So I'm Garner. Pete said I'm one of the people who organised this shower of rubbish. My day job is a CTO at Final Stage in Manchester, and I've been developing software on the Microsoft stack since before the internet, since the dawn of time. So the first things I used were Visual Basic 3 and SQL Server 4.2 before the internet was born. Those are both the first versions of those products in typical Microsoft versioning style. There was a VB2, but that didn't work. A VB1 only ran on DOS, which kind of stretches the concept of visual to its extreme, really. And SQL Server 4.2, I don't know what happened to 0.1 or 0.0. There wasn't a version 2 or a version 3. Version 1 didn't even run on Windows. So it was a non-Windows Windows database. It ran on OS 2, I think. So back in the very, very early days, I was writing software on these pre-internet platforms. And then we were writing software for the PC. And in the last 15, 20 years, everything has moved on as we've got more and more platforms on which we have been able to build our software. So we started off on the PC, and then we've got stuff that runs on the server, got stuff that runs in the cloud. Those are all fairly standard places for software to run. And then we've got all these new form factors. So in the last few years, we've got the advent of the tablet, console, phones. See, I can't let it lie. I'm not giving up. It will be back. And embedded devices as well. And as developers, if you're working on any of these platforms, you are blessed with a fantastic range of platforms, development tools, and languages on which you can make things happen on all these platforms. So on PC, you've got .NET Framework and stuff like that on the server. On the cloud, we've got .NET things, we've also got Node and stuff like that. I have no idea what happens on consoles because I don't get involved in any of that kind of stuff. On the phone, we've got the low-level stuff like Objective-C and high-up stuff like Swift and Xamarin to run things there. And on embedded, we've got all sorts of esoteric and weird things for you to write your software on. And lots of different bits of tooling as well to do all this stuff on. And that's all fine, except there's one problem. And that's here, in the browser. Because in the browser, we're pretty much stuck with JavaScript. Okay, there's things that transpile down to JavaScript. But the browser is a much more closed place to do development than lots of these other platforms are. And that's because the browser is effectively a runtime for JavaScript. It's a container which started off life as a presentation device for rendering HTML, but over the years has grown with more and more features being added to it as JavaScript has become more powerful. People have asked it to do more things. So we've got into this kind of arms race where the JavaScript engines have got better, so people have gone, oh, we can do more stuff on the browser. So we get more things happen on the browser, and that has shifted the emphasis from the server doing all the work, doing some work, rendering some HTML and pushing it down to the browser, to now the browser doing lots and lots of the work in and of its own accord. And that was fine when we were sort of starting out. We got a bit of scripting to do, a little bit of pizzazz on our HTML pages. But now we're asking the browser to do loads and loads of really advanced things. And it's trapped in this sort of single silo of running JavaScript. And that's because the runtime engine in the browser is effectively a JavaScript interpreter. So it consumes JavaScript, it runs it through the runtime, and then does something with it. So in the inside the browser, this is a simplified view of what's going on. I pinched this slide from a guy called Dave Glick, who has written some blog posts on this, and so simplified version of what's going on inside the browser, inside the runtime, is the 3 steps. So there's a parser, the compiler, and then that feeds into the JIT interpreter, which actually does all the work when you've done that process. And it's the interpreter that can talk to all the web APIs in the browser, and the interpreter sits at the end of that pipeline of things that happen when you start to run JavaScript. And this is a very effective way of running an interpreter. But the problem here is the pipeline, is you've got to go through all these steps in order to get something to happen in the browser. And writing interpreters is not particularly easy. Writing efficient and fast interpreters is particularly difficult. So there's no real incentive for the browser vendors, browser suppliers, I suppose, so don't pay for them anymore, to write a JavaScript engine or a runtime engine that works on anything other than JavaScript. It's too hard. Why would you do it? You can have an enormous browser. Why would anybody want to use it? So we're stuck with this this JavaScript silo, or we have been stuck in this JavaScript silo until now, with the advent of WebAssembly. I'm not going to read that horrible description. That's their own definition of what WebAssembly is. Give you a chance to read it? Right. So WebAssembly is a feature that's now been implemented in most of the major browsers, and it's only been really around for I think about 2 years. What it allows, what it purports to do, is provide a mechanism by which we can compile some source code and inject it into the runtime, bypassing the parser and compiler step. So we are skipping some of those steps. It's designed, as they say, to be fast, efficient, debuggable. It's an open standard, and it's currently at its what they describe as the MVP, the minimum viable product stage, and it is definitely not a mature standard, because they are asking for feedback on how it's being used, what's people's pain points with it, and they've got a roadmap with lots of things they want to put into it. And I sort of dug around a little bit and had a look inside, and then closed that box. In my head, I compartmentise everything in work into 3 boxes. Things I need to know right now, like how to start Visual Studio, how to write SQL queries. Things I need to know exist and I might need to know one day. So things like maybe Docker or F#. And things that I don't need to know about at all. I just need to know their mere existence and the headline of what they do. This works, incidentally, for things like pop music and reality TV programs as well. So this is my Love Island. I know it exists. I know what channel it's on, so I can avoid it. I just merely need to know that it exists. Underneath, we don't really need to know how this works. We just need to know that it does work and what it allows us to achieve. It's quite clever underneath. And when we've got WASM, which is a horrible abbreviation, in the equation, what we're doing is we're now being able to inject these .wasm files into the interpreter and bypass this parser and compiler step. So this is a bit like getting your ready meal from Tesco's. Before, we were having this cooked from scratch, so we were buying our chicken and cutting it up and making our tea. Here we're getting our ready meal. Someone's done a lot of the prep for us and we're just doing it. We're just whacking it in the microwave. Winner, winner, chicken dinner. That's the way to think about it. So the interesting thing about WASM is it's a binary format, and it is designed. It's a standard, so it's designed to a particular standard that all the browser manufacturers have implemented, and it is a low-level bytecode language, and the idea is that essentially you can compile any source code to a WASM file. So essentially all you need to do is you need to find or write a compiler, and as long as you write your compiler so it can consume whatever source code you want and can produce a WASM compatible file, you're on a winner here. You can write in any language you like, because essentially your compiler is now doing a lot of the work that the bits further up the pipeline needed to do. And because you're now doing this at a build step, in a compile step, you've got more time to do things like optimizations and code internal refactoring and resynchronizing things, the things that compilers are good at, and that you don't mind paying a little bit of price at build time in order to get the advantage of when you come to runtime. And so, because WASM is standard and we can take any source code and compile it into this WASM file standard, the guys at Microsoft thought, well, that's interesting, because that means we can compile anything we like down to a WASM file. So Steve Sanderson, inside Microsoft, thought, I wonder if we can do this with some .NET stuff. So he took a portable version of .NET framework called .NET Anywhere, and successfully, with a bit of tweaking, compiled it to a WASM file, and managed to get it working inside the browser. And then he thought, well, if only we had a standard way of mixing C# files and HTML markup in a single file. That would be really handy. And of course, Microsoft got Razor, which is the ASP language for doing just that, mixing bits of C# and HTML in the same file. So he's got all the bits, the components to get something working to run .NET in the browser. And turns out that .NET Anywhere doesn't work very well as the target for the framework to run inside the browser. But handily, in another room somewhere in Microsoft, they've got a portable cross-platform .NET framework lying around called Mono. So they took that and they used that instead, and they successfully got Mono working inside the browser. And putting all these pieces together, they've come up with Blazor, which is browser and razor together, portmanteau word. And Blazor is now a thing inside Microsoft. It wasn't not long ago, I think it was a thing inside Microsoft, but now it's a thing inside Microsoft. So people know about it and are talking about it, and a lot of people are really interested in it and seeing what it can do. So when you fit Blazor or WASM into the tool chain, this is how things look. So there's a bit of tooling you install and things, but basically this is what's going on when you're running this in the browser. So your application gets compiled to a DLL, and this is the runtime framework delivered from Mono, which references all the runtime bits, all the .NET runtime bits. And then the Blazor page references these two files, which they're responsible for loading the Mono into memory and then connecting your Blazor page to the browser, either through the compile stuff or through JavaScript interop. So what's happening here is this compiled part of the application is responsible for providing all the services to the bits that you write around the back and the bits that you write on the front. This kind of idea, this stack, isn't particularly new. This idea of being able to compile some source code down to a sort of intermediate byte format and then put it inside it and get the runtime to run it, that's quite an old idea. And in fact, that's exactly what you're doing every day when you run some code on the .NET framework, because internally, that's the way the framework works as well. The .NET runtime doesn't understand curly braces and angle brackets and generics and stuff. The .NET framework operates on an intermediate language, which the output of the build process in Visual Studio produces. So this is something that we as Microsofty developers have been doing, well, possibly by being known about it, for the last 15 years. And it's interesting that the name of this is WebAssembly, because assembly is quite a Microsofty phrase. So Microsoft have been quite involved at the beginning of this as part of the development process, and have been pushing this pretty hard. It's interesting that they've picked the name WebAssembly for this, I think. It's now implemented in all the major browsers, I think. As a standard, I think that if for any crazy reason somebody might decide to throw away their existing browser and start to write a new one from scratch, and who would do that? Why would you do that? I'm pretty sure that WebAssembly would be one of the main standards that would get implemented as you decided to build a new browser. So, what does my next slide say? It says this. So how's it work? So the C# and the Razor files are compiled into assemblies, and the assemblies are then delivered to the browser. The Blazor bit bootstraps the runtime, and then Blazor maintains a virtual DOM. When you make changes to the virtual DOM, only the changes are propagated to the live browser DOM. And that's the same way that quite a few of them, the newer modern frameworks work like React and things like that. And then Blazor can use the JavaScript interop that's built into it to talk to the browser APIs. And for browsers that don't support WebAssembly, there's this asm.js polyfill, which allows them to work. I'm not quite sure how that works. I haven't really dug into that. So the asm.js allows it to effectively run, even though it can't run it as WebAssembly files. Because why would you do it? And I guess for some of us in the room, we do it because it's nice and comfortable, nice cuddly feeling. We can use C# again. Hooray! But obviously, if we've got a .NET framework running in the browser, we can use any .NET compatible language and any .NET compatible languages that evolve in the future we can use in the browser. So I think this must have come from a marketing slide. Innovative languages, continually evolving. Well, that's true in some cases. I think our favoured VB.NET developer's not here tonight, Paul, is he? Unfortunately. So maybe he's retired. But of course, one of the key things is because Microsoft builds some really good tools to do this kind of stuff. Visual Studio, Visual Studio Code, really good places to work, regularly updated, almost too regularly sometimes. And the framework provides a really nice feature-rich platform to work on. And WebAssembly should allow a wide range of browser support as we go forward, as long as any new browser vendors implement WebAssembly. So the key components that you get to build Blazor applications are these bits. So there's the sort of design time support, which gives you IntelliSense, the Blazor.browser library, which contains all the bits that get delivered to the browser. There's a library with the SDK and all the buildy bits that run it all together. And there is a command line interface as well, which allows you to do various bits and bobs. And at the moment, because this is sort of a beta product, there's a few things you need the command line interface to do, because they've not been implemented in the tooling support yet. But things are changing quite quickly, it seems, in the world of Blazor, because it seems to have got a lot of attention very quickly. I am not an expert on this technology. I started looking at it about 2 weeks ago. So I know barely more than you do. So it's described as a experimental release. Now, I don't know what experimental means. This is my understanding. I think this is my interpretation of what they mean by experimental. It's not really a beta product. It's not really, they say don't go building production applications on it. But I've already started. Don't tell them, oh no, I'm being filmed. But it is a bit more than alpha, because it's actually getting quite a lot of interest from a lot of people. So it's gaining some traction and gaining some momentum. Currently version 0.4, which was released last week, and has a few bits added to it. And in order to get it to run, you need to install the latest .NET Core SDK 2.13 or later, and an up-to-date version of Visual Studio 2017 with the tick box for ASP.NET and web development ticked. There is a there's a bit of confusion in the documentation depending on which bits you read as to whether you need a really up-to-date version of the RTM release of Visual Studio, or whether you need the Visual Studio preview release, which is kind of the not yet released version. Some places, some documents say you need the preview, and it won't work without a preview. Some bits say you need the latest version, and the preview won't work. I've got the preview version running on my machine, and it works fine. So, and version 4 seems to work okay on preview, so I'm quite sure what's going on there. And then there's a language services extension which you need to obtain from the Visual Studio marketplace, which gives you all the bits and bobs, the toolchain and stuff, IntelliSense to make this all work. And there is a rapidly growing site of documentation for how this all fits together at Blazor.net, which has got a fair bit already on how it all works, how it all fits together, and some documents even by Steve Sanderson. Steve Sanderson seems to be the guy who's who's pushing this, making this happen inside Microsoft. I don't know him, but he's obviously a Brit because he talks.
He did Knockout.js.
Oh, did he? Is he Knockout.js? Right. Okay, right. So Steve's the guy who's running it inside Microsoft, and so that's a quick run through of how Blazor fits together, how it works. Okay, so I'm going to do a demo run through of a few bits of Blazor. It's not a particularly exciting demo, but I'll just show you how things go together. I'm going to sit down for this bit because I've been writing software since VB3. So I've got the Visual Studio preview version here. So to create an application, we do the usual thing of going to create a .NET Core application, and our wizardy thingy pops up, and we've got two options here. I'm going to pick just the straight vanilla Blazor application, but the ASP.NET hosted one produces a couple of extra projects when you create it. There's a client project which is the same as what we're going to look at now, and there's also a server project which is a fairly standard web API backend project, and it also produces a library project as well, in which you can put your model classes, and they are auto-magically shared between the client and the server class, which hopefully makes things a little bit easier in building when you're building things that are a bit complicated. So if you have recently started a new ASP.NET application, all this stuff here will be quite familiar to you. So this is a fairly standard file, which project you'll recognize from doing any kind of ASP.NET stuff. If I actually run this, and the first thing to note is that there's no debugging support at the moment for Blazor, so you have to run it run it without debugging, but it will go away and build, and in a moment it will produce a vanilla application which takes a few moments to get going, and when it appears you'll recognize it as the pretty standard template that you get with all the ASP.NET stuff at the moment. So we get one of these counters, we can click and increment, and we've got a page that simulates going and getting data from a web service. So the index page, which is that first page we looked at then, you can see is really quite simple, and this is our first look at actually seeing some code in the browser. The counter page we just saw then. So it consists of a page directive at the top. That's telling the router. I can try and make it a bit bigger. Yeah. Is that better? So that's the directive to tell the router to where to route calls to, and the rest of it is pretty standard razor type markup. And then we've got this bit at the bottom with the functions inside the curly braces bit. And this is pretty simple, so we can just do usual kind of thing where we can change the counter. If I then refresh the page, we should get back a new application, and now I can go up in tens. Pretty simple. Everything inside Blazor, all these pages are treated as individual components. So what I can then do is I can add if I could spell, to the index page. And if I do that and refresh, we will see the counter now appearing on the index page as well. Pretty simple kind of concept of components. These components are pretty clever. We can then add I'm going to add a parameter to this component, which I'm going to call amount. I'm going to make it a property. I'm going to give it a thank you, Mr. Martin. Red squiggly, of course, because Martin's told the compiler to tell me off when I do things wrong. So now, with this increment, I can then go on to here and add a parameter to that directive. And when I refresh, eventually, it takes a while to come back, I'm now adding 25 on this one, but the original one is still going up in ones. So we parameterize that component so we can use it in different places anywhere. And the component model inside Blazor is quite sophisticated, and it understands hierarchies quite well. And there's some interesting stuff that Steve Sanderson's done on one of the NDC demos of using a component with that understands its content to do things like spinners and graying out over pages when things are loading and that kind of stuff. It's quite neat. So that's the kind of the way the components work. So we'll do a little bit something that's slightly more interesting, and we'll create a new page on here. Raise view. I'm going to call this to-do list. So that creates a to-do list page, which is a component, and I can then just go to-do list on here. Save that, and then in the navigation menu, I will just copy and paste one of the existing ones just for the ease of. I think I've turned resharper off. Yeah, resharper was really quite unhappy with some of the stuff I was doing on this last night. I was getting knickers, quite a bit of a twist about stuff I was doing. So resharper obviously needs a bit of an update to do with this, and then obviously to make this routable, I need to add, see, sometimes it's getting a bit. The tooling obviously is a little bit that's not good. I'm writing too much. And a keyboard that doesn't work either. Oh, for fuck's sake. You'd never believe I've been actually coding for 20 odd years, would you? Don't tell my boss. I can't type. So hopefully now we should have a to-do list, which takes us to a to-do list page. So that's just a quickly created new component, and then what we'll do is we'll start to add a bit of functionality. So we have this functions section, and in here I'm going to create a class which is, don't you love watching people type in demos? It's really exciting, isn't it? Sorry? Well, I could have done code snippets, couldn't I? But that would have meant me staying up till about 3 AM instead of 2. So we're going to go for a pretty canonical representation of a to-do list, and I'm going to create a list of to-do items. And then in order for us to actually see if we've got anything in the list, what I'll do up here is I'll add to-do items.count. So nothing obviously will happen if I run this now. So what I need to do is create a quick method. Don't like that, do it? Right, let's try that. Okay, so now if I add a to make this work, we can start binding things together, and we can bind using this simple directive like so. Now, with any luck, hopefully what have I done wrong? Something like that. Let's just start it again, just in case it's got itself in a twicky. Because what I've done is the wrong thing. I need to go on click. That's what I need there. And then we should be able to run this again. And on our to-do list, we should now be able to add things to our list. So we've got the sort of basics of what's going on here. Let's have a and then we'll just go. No, I need a list there, don't I? And I can bind to item.text. So now in our application, when I'm adding things, we should now be seeing the new items added to the list. So you can see it's all starting to come together with a bit of binding and a bit of stuff. So what happens if we want to be able to change our status? We can, in here I can add an input of type checkbox, and I can bind that. That's where the binding comes into the item is done property. So we then should be able to change the state of these items, and so we can actually see if that actually does anything. What I'll do up here is I'll just add a bit of linkiness to see this in action, and I think then we should be able to see I can add a few, lost a parenthesis there, but I should be able to now see that as I click on and off, we're changing the state of those individual items in the array. So I guess the last thing we will then probably want to do is we can change this input, and we can bind that to item.text. It's very quiet in the room. Can't tell if you're impressed or you're asleep. So I can add a few things. Sorry, yeah, it probably is. Actually. And I can change these different items, and that's happening in the back end. So you can see there that basically the way this works is operates on quite a component-based level. All these individual pages are addressable as components. You can move them around, put them in different places, and all the basic plumbing bits are all here in order for you to build pretty functional applications out of the box. Now, I haven't pushed this very hard at all, because I've only really been looking at it for 10 days or so in reality, when realised there wasn't anybody to talk tonight, so I thought I better come up with something to talk about. And this has been I've been seeing this sort of come past the radar quite a bit over the last couple of months, and thought it'd be interesting to look at. And it's been pretty quick to pick up what's going on and see how to build these kind of simple applications quite quickly. Now, how well it will work when you start to get complicated, I don't know. As I said, when you build when you start the other project, the ASP.NET hosted project for Blazor, you get this project, you get a server-side project and a library project. And now I played around with that for about 5 minutes, did that thing to the counter page, and then thought, well, I'll have a crack at this and try deploying it to Azure. And it worked, just like that. The server project has all the bits in it to understand how to serve the client-side project. So you deploy the server project as a package, and it just, I was surprised because I wasn't expecting it to happen. I hadn't read the docs, that's what it's supposed to do, but it just worked straight out of the box. It just deployed, and within half a minute, I was clicking my counter button on Azure to my heart's content. So it's all sort of coming together, all the bits and pieces are coming together, and whenever you hear Steve Sanderson talk about this, he always sort of says, what we need is your feedback of seeing how this works in action. And that initial index page on there has got a link on it for a survey to fill in if you start to use Blazor, to give them feedback on how it's going. I have got a little bit of a project I need to build over the next couple of weeks, which I was just going to throw together as an ASP.NET project. But I think I might try this in the next few weeks and just see how far I get in actually producing something that will actually work in the real world. And it's got some of the things that start to trip things up that you don't see in the demo. So I'll need to connect to an Azure database, and I'll need to be making some calls to a web API, and I'll need to be rendering things in tables and doing edits in tables and that kind of things. Those things that you never see in demos, but are things you really need to be able to do in order to deliver a production application. So I'm going to be trying this out in the next few weeks to see how it works, and I've got reasonably hopeful it might do what I need it to do, but I won't be particularly disappointed if it won't. I'll be disappointed I've lost 3 weeks' time building it, but at least I'll be able to report back and tell you how well I got on. I hope that's been an interesting kind of quick tour of Blazor. I'm not an expert, as I said. I've only been playing with this for a couple of weeks. I am quietly impressed at how quick it was to start doing stuff. There's some stuff that I've not shown you that's in some of the demos, which is quite nice. There's a much more advanced demo which simulates a sort of flight search application, like Skyscanner type thing, and that is a really nice demo. Looks really nice, and Steve's got some nice features implements on one of his NDC talks in that, with some proper, more production-y kind of bits and bobs in it. It looks really, really nice. So it obviously has the ability to do interesting things. I guess the question will be is if it starts to gain traction, and if people start to use it, people start to feedback that it's interesting and people are prepared to try using it, then Microsoft will probably start putting some more effort and some more interest into doing it. The one thing I didn't mention when I was talking about WASM files, say it again, the WASM files, is that the approach that these guys are taking is slightly different to the approach that I think was originally envisaged for WASM, because I think originally WASM was envisaged as delivering pretty much an entire pre-compiled application to the browser, whereas what is going on here is they're delivering the runtime to the browser and the bits that make Razor work. So it's a kind of a hybrid of a fully delivered application and the runtime bits. So it's an interesting approach. I'm sure, given that the documentation pages are getting completed quite quickly, and Steve Sanderson seems to be getting a bit of a higher profile, that there's obviously some people inside Microsoft who are interested in this and seeing how it progresses. I hope you are too. I will let you know in a couple of months' time how I got on with actually building an app in something approaching the real world with Blazor. But that's all I've got to tell you tonight, I'm afraid. I am now finished. Pete.